Now we're, just continuing on in lesson 10.6. When we talk about the odds of an event, we have to treat it a little bit differently than we do the theoretical probability or even the experimental probability. When we talk about odds, like in this first one here, when we say, if we want to know what are the odds in favor of something happening, upstairs, we're looking for the likelihood that that event would occur. So odds in favor, would you put a box around that, please? Odds in favor. So if they say, what are the odds in favor of? Upstairs, you're going to put the number of ways the event can happen. And downstairs would be the number of ways the event can fail to happen. So you remember that, I talked about when they give the weather, they always talk about, what the percentage is of chance of rain. So this morning I heard that there was a 30%, I think is what I heard, a 30% chance of it raining this morning. Well, if there's a 30% chance of it raining, what's the chance of it not raining? 70%. So the odds in favor of it raining would be stated something like this, 3 to 7. So in favor of it raining. If the ways it can happen is 30% of the time, we're saying 3 times out of 10 it could happen, but they're going to fail to happen 7 times out of 10. Okay, so the odds in favor. When it's the odds against, now we're talking about the number we put first is, well, the odds against it raining are 7, or a 70% chance it's not going to rain, and we're going to compare it to the likelihood that it will rain, which is 30% or 3. So then we would turn it around, it would become 7 to 3. Okay? So we have odds in favor, and let's put a box around this. We also have odds against. Okay? So you have to make sure you read the problem carefully and ask, what is it asking for? Is it asking for the odds in favor of something happening or the odds against it happening? Okay? So let's look at the example that they have here. The odds of winning a game are 3 to 7. What happens to just be those same numbers? What is the probability of winning the game? Okay? So determine the number of ways to win and not to win. So let's underline that. The odds of winning a game are 3 to 7. So what's the 3 representing? Right?
Your chances of winning.
Your chances of winning, the ways to win. What's the 7 representing?
Not winning.
Cameron?
Chances of not winning.
The chances of not winning are the ways not to win. So in reality, altogether there are what? 10 things that could happen. 3 ways to win, 7 ways not to win, altogether there are 10, aren't there? So if we have to find the probability, now we have to add those together because in probability, not in odds, but in probability, the downstairs is the total number of things that could occur, right? So in this one, if the odds of winning a game are 3 to 7, there are 3 ways to win. Let's underline that. There are 7 ways not to win. So step 2, find the total number of outcomes. So we add the number of ways to win to the number of ways not to win, and we say the total number of outcomes. So let's put a box around that 10, and let's put a box around the total number of outcomes here also. So we have to find the total number of outcomes when we're talking probability. We always need that total for the denominator in probability. So our learning goal today is I can convert between probabilities and odds, or vice versa. I can convert between odds and probabilities. I know how to work with them together. And so what we're doing here is we're taking odds that they gave us and we're converting it to a probability. So find the probability of winning, because the ways to win is 3. Out of the total outcomes of 10, we set up 3 over 10, and we know that 3 over 10 is 30%. So it's kind of like my weather example, turns out to be, doesn't it? Okay, let's go look at the other side here. Convert from probability to odds. We just converted on this side over here. We were converting from odds to probability. Now what if they give us the probability and they want to know what the odds are? So the probability of winning a game is, so this is a different game. The probability of winning a game is 10%. What are the odds in favor of winning the game? Okay, So you write the probability as a fraction first. So 10% is 1/10. Then it says find the number of ways to win and not to win. Okay, well, there's a 10 downstairs. This is total. Okay, so let's put that by that 10. This is the total outcomes. Remember, we always have the total outcomes downstairs in probability. And this is probability. It was a percent, renamed as a fraction. And what's that 1 upstairs then? What's that 1 representing then? If it was a 10% probability of winning, so the 1 is representing what? One way to do what? To win. That's the event. We want to win. The probability of winning is 10%, so that means there's one way to win. So that 1 upstairs in probability is saying, you know what, if the event was the probability of winning, then the event is winning. So that 1 upstairs is representing how many ways can I win? I can win 1 way in this game out of 10 total ways. So now I can figure out how many ways are there not to win. What do I have to do? If there's 10 total and there's 1 way to win, we do a subtraction problem. So notice what they did right here. So 10 take away 1 equals 9. What does that represent? What's that 9 represent?
How many ways all the other probabilities?
So the ways not to win? Yeah, there are 9 ways not to win. So there's 1 way to win over 10 total ways. Well, out of 10, if only 1 way is to win, then that leaves 9 to not win. So now I'm ready to set up my odds, because odds are what ways of winning compared to ways of not winning. So now I can say the odds in favor are 1 to 9, and we can write it either as a fraction or as a with a colon between. We can write ratios either way. So the odds in favor of winning this game are 1 to 9. So when we look at that, they say, what are the odds in favor of winning the game are 1 to 9. Because if we say to ourselves, well, there's a 1 first, so they're saying there's 1 way to win. We look at the other one, we say, well, then that means there's that many ways not for not to happen. So there's 9 ways not to win. Okay, let's look at number 6 then. This is, called number 6 because we're carrying on from the front side. The odds in favor of winning a game are 1 to 20. What is the probability of winning the game? Now, we're going to have to do some work that's going to show us how we're getting our answers, okay? So if the odds are 1 to 20, let's put that, odds, and let's write it like this, 1 over 20. If the odds are 1 to 20 of winning the game, what's that 1 representing?
Well, winning.
Ways to win, right? Yeah, that's ways to win. So there's 1 way to win. And what's the 20 representing? No, this is odds.
No.
This is not to win. Those are ways not to win. This, when they give it as odds, remember, it's not over total. It's over the other thing that could happen. So we have 1 way to win, 20 ways not to win, and we're supposed to find the probability of winning the game. So we need, when we do probability, what do we need downstairs? What do we need downstairs in probability? What do we need downstairs in probability? I'm waiting on you. Total. So we need a total, don't we? So the total will be 1 plus 20, and what is that? 21. Are we ready now to find probability of winning? What would we do to find the probability of winning this game given the odds in favor of winning? 1 over 121. Can 1 over 121 be simplified as a fraction?
No.
Anybody think they just happen to know what the decimal name is for 1 over 21?
fractional.
let's, it's not 21%. 21% would be what fraction?
Yeah.
What fraction would, oh, don't be all arrogant here. What would 21% be as a fraction? Not 1 over 21. What would it be?
21 over 1.
Mm,
21/100.
21 over 100 would be 21%.
21.
So let's see your calculators. Let's do 1 divided by 21. And I will let you round it to the nearest whole percent. So 1 over 21. What do you have to do to also change it to a percent? Multiply by 100 and round it to the nearest whole percent. Yes, Brayton.
I got 5%.
Is approximately 5%. Why do I say approximately?
It's
Because
not.
we rounded, right? Yeah, so we rounded. So its fraction probability is 1 over 21. Changed to a percent, to the nearest whole percent. We'll go today. It's approximately 5%. Everybody agree with Brighton that it rounds to 5%? Yeah? Okay. Anybody have questions about that one? Okay, I want you to try now setting up, doing this part, you know, the work part here, and then this part. Try that. Try doing that on your own on number 7. The odds in favor of getting tickets to a concert are 4 to 5. When you're done with that much, see if you agree with me. Odds in favor of getting tickets to a concert are, so the first number always represents what is it that they're stating. They're saying getting tickets. So the 4 represents, you have
4 represents
4
the
ways
chance
to
of
get
getting
tickets, right? And the 5 represents you have
No tickets.
5 ways of not getting tickets. We need a total because they want us to do probability. Okay, what would be our probability fraction in this one? What would be our probability fraction? 4 over 9. What's the probability of getting tickets? 4. Remember, there's 4 ways to get tickets out of 9 total ways. Oh, and we already know what this is going to be. Remember, a 4 ninths is a what? Point what? Repeating? 0.4 repeating. So we're going to have a 0.4 repeating. We're going to move the decimal point over 2, and we'll still have, so we'll have 2 4s in front and a whole bunch of 4s behind it. We're going to round that to the nearest whole percent. What percent would 0.4 repeating round to? Cameron?
44.
44%. So I'm letting you round to the nearest whole percent for the probability when we're doing these odds. So you have about a 44% probability of getting tickets to the concert. The odds were 4 to 5, which should make sense, right? If the odds were 4 to 5, it's kind of sounding like, you know, it's not very likely that we're going to get tickets. Okay, notice how they state number 8. The odds against winning a contest are 98 to 1. So let's write it as a fraction first. Remember, we write our odds as a fraction first, so that then we can identify what our numerator and denominator say. So 98 to 1 would be 98 over 1. So that's 98, the odds against winning a contest. What's that 98 represent?
Winning.
Yeah, not winning, right? 98 ways not to win. not to win, and the 1 represents 1 way to win. It's really important that we identify this stuff first, because then it helps us when we have to convert it to a probability. Then what do we have to do next? We gotta find a total. We gotta add those together. So our total is 98 plus 1, which is 99. So now the probability of not winning the contest. Now you have to make sure you read both of them. They give the odds. Sometimes they might ask you for the other probability. So be really careful. Always read what they're asking you for. So we kind of converted, we figured out what 98 to 1 odds means. Now it says, what is the probability of not winning the contest? So what goes upstairs? The ways not to win, right? So what are we going to put upstairs? 98. And then downstairs we put the 99, the total. And then we divide that out and we round to the nearest whole percent. Right?
I got a 98.
You got 98 with an 8 repeating. So 98, 98, 98, 98. Okay, so you got a 98.98. What would that round to? 99. So approximately 99% probability that you will not win that contest. So that gives you a probability of about what? Winning? 1%. There's 100 take away 99 would leave a 1% chance of you winning that. Okay, that's converting from odds to probability. Anybody have any part of that that's still unclear? Odds to probability. Now we're going to reverse it. Questions? This is tricky, and I need you to know how to do it. Okay, number 9. Now we're going to convert from probability to odds. The probability of choosing a marble, blue marble, is 60%. So let's do it like this. Probability blue, that's how we write it. Probability blue equals 60%. Well, in odds, they don't typically start out as a percent, do they? They start out as a fraction or a ratio, right? So we need to change this to its fraction name. Trey?
How are we supposed to change it if we don't know if it's 60%?
Well, what can we do with, if we want to get rid of the percent sign, we can put 60 over what? 100, yeah, 60 over 100. And 60 over 100 simplifies to 6 tenths. No, we're not going to change to a decimal. And 6 tenths simplifies to, no, we're simplifying it as a fraction. 3/5. 3/5. So in reality, we could have taken 20 into both of them right away. You can take 3 20s out of 60. You can take 5 20s out of 100. So 3/5 is the fraction name for the probability 60%. That's where it came from. Okay? So now, when we write that as odds, oh, just a second, erase that. What is that 3 telling us upstairs? Trey?
We'd have like 3 times out of 5 we'll get a blue marble.
Okay, so this is 3 blue out of 5 what? No, what's the 5? It's probability. What's downstairs in probability? Total. So there's 5 total marbles, of which 3 of them must be blue. Every 5 marbles, there must be 3 blue ones. Or every 100 marbles, there must be 60 blue ones. Or every 10 marbles, there must be 6 blue ones, okay? So that's what the probability tells us. Well, when we need odds, and we want the odds in favor of choosing a blue marble, well, if there's 10 total, and 6 of them are blue, how many are not blue? Oh, I'm sorry. We had it down to 3 and 5, didn't we? Yeah. If there's 5 total marbles, and 3 of them are blue. How many are not blue? 2. So we do 5, take away 3 equals 2 that are not blue. 5 take away 3. We gotta figure out how many are not blue because when we do odds, we compare them to how many of one, and then that means how many of the other. So what would be the odds now then in favor of choosing a blue marble? So what has to come first are the blue marbles, and what has to come behind it has to be the not blue marbles. So how are we gonna write these odds?
Would it be 3 and 2?
It would be 3 to 2. It'd be 3 to 2. These are the odds in favor of blue. There are 3 blue, there are 2 that are not blue. Remember, that's how odds are compared. So if there was a 60% chance of randomly selecting a blue marble, it has an odds in favor of it happening 3 to 2. So what would be the odds against selecting a blue marble? What would be the odds against selecting a blue marble, right?
2 and 3.
Okay, so there's 2 that are not blue, and there would be 3 that are, so then it changes around, doesn't it? Now it's 2 to 3. Okay, how about number 10? The probability of a spinner landing on green is 20%. How do we start? We rename it as a P green. Oh, I should just use green. That would be fun. So P green. That's a color, isn't it? Okay. Equals 20%.
Equals
And 20% as a fraction is 20 over 100. And 20 over 100 is the same as 1/5 or 2/10, but eventually it'll get down to 1/5. Yeah, 1/5. That's the probability as a fraction. So now we say, what does that 1 upstairs represent?
Green.
What's the event?
1 of the green.
Getting a green. We want a green.
total.
And downstairs is the total.
5 minus 1 equals 4. And then you're probably.
Okay, so when we take 5 and we subtract 1 and we get 4, what is that 4 representing?
Other colors.
Other colors, so not green, right? Can we say it that way? Not green? 4, not green.
1 and 4.
So now now we gotta go back and read the question, and what do they want? They want the odds in favor of the spinner landing on green. So they want green. So it'd be
1, 4.
1, 2, 4. Now, yeah, we'll write them as ratios. Okay, like that. 1 to 4. And this is in favor odds in favor of green. Okay, you got this stuff?
Yep.
Questions? Right?
Alright, so if it's saying the odds that are in favor are of a certain one, and you end up writing it backwards, would it be considered wrong, or would it just
There's only one direction to write it if you're going to write it correctly. Because is 2/3 the same as 3/2? No, it's not, is it? So yes, there's only one correct direction to write it. That's a good question. Anybody else? So make sure though that you're careful that you're reading always, because they can try and trip you up. Here they'll give you the probability of landing on green, and then they might ask, what are the odds in favor of not landing on green? And they can switch it up on you, and they might do that. So make sure you read. Don't be in a hurry. Okay, let's go to work on homework then.